Today we're doing everybody's favorite pastime, watching someone weld on the internet and telling them everything they did wrong. Though in my case, the criticism is well deserved.
Welcome back to Cloud 42. I'm James. A long time ago, in the before time, you might remember that I'm building an Avid CNC router with a Centroid Acorn controller and ClearPath servos. That project got put on the back burner because reasons, but today, it's back. Previously on Cloud 42, I assembled the router, fitted the motors, built the electronics cabinet, and got it running well enough to do some glass cutting. Next up, we need to tram everything in, but I don't want to do that until it's in its final location, and that means we need to fabricate a stand.
This is the design for the router stand that I think I showed in a video almost a year ago, and the reason for that delay is this lista cabinet that is built into it. I ordered this from MSC and they quoted me 3 weeks lead time. 3 weeks became 6 months. One thing led to another, and here we are almost a year later, but we are back on the project today. This cabinet is a full depth lista cabinet, and it should provide plenty of storage for tooling and fixtures and anything else that I need for the router. And then it's wrapped in a framework made from 2 by 3 inch rectangular steel tube. I'm using 1/8 inch wall tube just because it's easier to weld than the thinner wall stuff, though thinner tube would probably be sufficient. The extra weight will probably help with vibration though. I've got some rings that I'll weld onto the top here, and this will just keep the feet of the router from walking around so that it doesn't vibrate and find its way onto the floor. And then on the bottom, I've got a set of 4 FootMaster casters. These are rated at 500 pounds per corner, and they have a ratcheting mechanism that lowers a solid rubber foot that will lift the whole thing off the ground for stability, or it can be raised up so that it can be wheeled around. And then on the back, I've got 3 pieces of strut that will allow me to attach the cabinet just so that it can't shift around and give me a place to mount the electronics boxes. Went ahead and created some drawings. These will be available on Patreon if for some reason you wanted to make one of these along with all the dimensions and the 3D model. But this will just give me the dimensions I need with a tape measure while I'm welding it up so I can locate the parts, and then a drilling plan for where the holes need to go to mount the strut on the back. So I think all we need to do now is go out to the shop and start cutting the tubing. This thing's not going to make itself. To cut the tubing, I am using my Evolution Carbide cold saw, and this thing makes short work of a project like this. It cuts through this tubing really quickly and leaves a nice clean cut. I really like the cuts that it makes, but it really makes a mess. In a previous video, I attempted to make a vacuum port for this that would catch a lot of those chips, and it caught maybe 60% of them, but it still makes a huge mess, as you can see. So I've just gone back to working with it down here on the floor. I might take another run at that someday, but for now, this is a pretty good solution. The chips don't go very far when they start this close to the floor. The saw does have a miter fence, so I can just swing it out to 45 degrees, drop in the pin, make the cuts, move it back to 90 degrees and make my 90-degree cuts, and it makes a project like this a lot easier. I could set this stuff up on the bandsaw, but my bandsaw doesn't have a positive stop at 45 degrees and it would take a lot longer to make the cuts, so I just live with the mess. The FootMaster casters mount to the bottom of the frame using a 1/2 inch threaded stud, and I didn't really think that the 1/8 inch thick wall of the tubing was really going to be enough to retain that, so I'm cutting out some discs made out of 1/4 inch steel plate, and I'll thread those and weld them onto the bottom, and those threads should hold securely. I'm also cutting out the rings that I need to secure the feet of the router to the top of the stand. I could have made those with a ring roller. I do have one, could roll those out of straight stock, but that seemed like an awful lot of work, and as long as I have the electric fire machine out, I might as well just burn them out of the plate. I can also pull this out later and make any other brackets or weldments or reinforcing gussets or anything else that I need for this project. The plasma cutter leaves a little bit of dross on the parts, but that is easily removed with a 60 grit ceramic belt in the belt grinder. I used to do this job with a right angle die grinder and Rolock sanding discs, but that's way more work than this, and the belt grinder ends up being a lot easier to control. I found that if you just hold the flat side of the part with the dross against the belt and just roll it back and forth on the tool rest, the sparking will die down once the dross is gone and the belt doesn't appreciably cut the surface. Then a nice quick swipe around the edge squares it up and leaves a nice clean surface for welding. Just like that, we've got 4 rings and 4 pads. Let's go cut some threads. I probably could just thread the holes in these plates directly, but the plasma cutter does leave a little bit of a taper on the wall, so I thought it would be better to come back and clean it up with a drill first just to make sure there weren't any tight spots and I didn't end up jamming or breaking a tap. I was a little bit worried that the drill would get hung up in some hard spots from the plasma cutting, but that didn't happen at all. It just cut right through it like butter. And with all the holes drilled, I just came back with a 1/2-13 tap. That is the thread that's on the FootMaster casters, and just power tapped them. And that went right through like nothing too. I was, again, concerned that there might be some hardness there from the plasma cutting, but it just didn't end up being a problem. The easiest way to drill the holes in the back uprights is here at the mill. I have a stop here bolted to the mill table. So I can take each of the back legs and I can just slide it down against the stop, clamp it in the dual vices, and use the DRO to locate the holes. I'm drilling these out as clearance holes for 3/8. That's the size of hardware I'm going to use to mount the struts to the back of the stand. So I can just drill the 3 holes in one side, clean it up, and then flip the part over in the vices and drill the matching 3 holes on the other side. And the stop ensures perfect registration between the 2 sides. And then of course, once this is done, I can put the other piece in and drill the 3 holes in each side of it. This is far easier than trying to do this with a hand drill after the frame's welded together. Since all the parts are still loose, I might as well grind the weld bevels here on the belt grinder. I'll start just by cleaning up any little burrs that were left on the end from the saw process, and then work on the outside corner first. There is a sharp corner here, and I'm just going to grind it down flat at a 90-degree angle, and this will leave a 90-degree V on the outside corner for the weld, and then I'll just put 45-degree weld prep on each side of the miter. This will make it possible to sink the weld all the way through and get full penetration, and also not build up too much material on the surface that I'll just have to grind off. This is the kind of project where a welding fixture table really shines. I have the part sitting up on top of 1/2-inch spacers just so I don't have to weld right down next to the table surface, and then I'm using pins in the table to make sure that the frame is square, or at least that one corner is square, and then I'm checking the outside dimensions to make sure that I have all of the miters butted up against each other consistently. Ideally, I would have left a 1/16 of an inch gap, but I didn't think about that, so they are butted tight together, and the whole frame is about a 1/16 of an inch oversize, which will be fine, but it would have been better to leave a gap. Now I'm starting the tacking with the outside corners, and I'm doing adjacent corners back to back, because the tacks on adjacent corners will tend to pull the frame out of square in opposite directions. So by working my way around in that pattern, the tacks will tend to all pull against each other and the frame will stay as square as possible. Now with everything tacked, I'll start by welding the outside corners. I'll do this with short stitch welds or just try to be very careful with the movement. It's pretty easy to blow through on this kind of a weld, so it does take some care. And I'm doing the same thing, doing adjacent corners back to back to try to equalize the stresses. And then I'll weld the inside using the same pattern. I did do some practice welds before I started on this just to try to get my hand in and make sure that I wasn't going to screw this up, and I got impatient with that and decided to just jump into the project. I mean, what better way to learn than to do? And it turned out okay. I'm doing these miter welds in 2 segments. I'm welding the inside half of the joint first and then coming back and welding the outside half. And again, just working my way around to try to equalize the stresses. I started out trying to grind these flush using my right angle die grinder and a roll-lock disc, but yeah, there's way too much material to remove, so I switched to a 5-inch cordless grinder and a flap wheel, and that did pretty well. Now's the moment of truth to see if this thing actually stayed flat. And actually, it did. There's basically no perceptible rock in it at all, so I'll flip it over and weld out the other side. Doing exactly the same thing, doing half of the weld on each corner first and then coming back and finishing it up. My travel speed on this first frame was a little bit fast, so there are some gaps in the welds where I didn't fully fill the weld bevel, but I learned something and I'll do better on the next one. Now with everything welded and unclamped, how flat is it? It's pretty flat. I'm impressed. This fixture table and the weld pattern I used did a good job. Now for the second frame, it's a little too big to fit fully on the table, so I'm using a pair of Fireball Tool aluminum minion squares with the little alignment tabs, and this worked well. So I've got 3 of the sticks actually clamped to the table and the other one out in space with the minion squares, and it worked just fine. I wouldn't want to do something too much bigger than this, but at this size, it worked okay. All the steps for welding this out, grinding flush, flipping it over, and welding the other side are exactly the same as what you've already seen. You can see the round spacers there on the table that I'm using. And again, that's just to keep the welds up above the table to reduce the spatter that sticks to the table, but also just to avoid accidentally welding something to the table. Followed the same pattern, got this welded out completely, and then it was time, of course, to brush off the welds and take some photos for the gram, and some of the welds look good, like this one. Each corner of this bottom frame gets one of these round pads for a caster wheel, and I'm just lining it up with the edge using a block. This is a 3-inch disc on a 3-inch tube, but it's remarkably difficult to align it by eye. I'll just use a transfer punch to locate the position here. I need to drill a relief hole behind this so that the screw has some place to go after it goes through the threads. And to drill the hole, I'm using a pointed drill bit. This drill has almost like a step drill profile on the end with a small point for centering and then progressively larger diameters to efficiently cut through hollow wall tubing. These are really ideal for fabrication jobs like this. In this case, I'm not just drilling through the tube wall, but also through the weld, and we get a chance to see what the penetration is like, and that looks like we've got full penetration and a nice fill on the miter. I'll locate the plate for welding using the screw. Just go ahead and run that through the threads into the relief hole, clamp it down, and weld this on with 4 stitch welds. I've got the welder turned up because this is 1/4-inch plate, but I don't want to blow through the 1/8-inch wall tubing, so I'm trying to focus most of the heat on the plate, and that went pretty well. Let me grab one of the feet and let's try this. This is the FootMaster caster that I'm planning on using. I'll just put the screw into the threads in the top and run this down on the plate. It should be simple, but it's easy to test now, so it's good to do so in case I have some kind of a problem that I can fix now rather than later when it's a lot harder. That looks pretty decent. The caster has this little pop-out lever that has a ratchet mechanism for running the pad down onto the floor. But for now, I'm going to go ahead and pull this off. It'll just make it that much easier to work with this until I actually need to set it up on the casters. Welding on the vertical members can be a little bit treacherous, and the fixture table unfortunately doesn't really help us here. I've fixtured up the first vertical here using a pair of the minion squares, and I'm checking it with a 246 block and a framing square just to make sure it's pretty close, and then I'll tack it into place. On a joint like this, the tacks have a lot of influence on the position of the part, and as they cool, they pull. And it's pretty hard to keep something like this truly square, even with it clamped in place. Checking again with the framing square, I can see that this leg has been pulled significantly to the outside. That's enough that it's going to be a problem. So I grabbed the angle grinder, cut off that outside tack. That's the one that shrank and pulled the leg to that side. And then with the tack cut, I can just pull it and bend it back into position. And then I'll re-tack it while putting some pressure inward on the leg, and that actually worked well enough. It's within about a 1/16 of an inch of square, and I suspect all of them are going to end up splayed outward in the same direction, so it's probably going to equalize in the end and be fine. I'll just work my way around, clamping each one of these up with the minion squares and following the same procedure, trying to get it tacked into place. And what I discovered is if I put a tack on the inside corner and the two diagonal corners and avoid the one on the extreme outside, just use 3 tacks, it stays a lot more square. And so that's the procedure I'm going to use for the other 2 legs. Now, I'm not welding any of these joints out yet, I'm just tacking them. We'll wait to weld them out until we have the entire frame tacked together. With all 4 uprights on here, I'll set this aside, grab the base, put that up on the table, and then stand it up on top. And this will be the full form of the table. You can see I've got some marks there that I'm lining the legs up with, and I'm clamping some blocks on the outside just to make sure that the outside edge is flush. And I'm going back and putting 1 tack on each leg just to try to get it rigidly held in position. I'm checking the diagonals to make sure we came out square, and that actually worked pretty well. So now it's just a matter of working our way around the entire frame and welding out all of the joints. And I'm trying to weld opposing welds back to back, so any shrinkage that's going to pull it out of square will immediately be compensated by the following weld, which will try to pull it in the other direction. This took quite a while, and I had to weld in all positions, so I've got some downhand stuff, I've got some overhead stuff, I've got some horizontal on vertical walls, and it all actually went pretty well. I learned a lot through this process. The next one of these I build will be better, but this one is going to be perfectly serviceable. With the frame all welded out, I will put the casters on it, and it's time to get this thing down on the ground. Of course, none of my pliers would actually fit into the narrow gap there, so I had to use the chain wrench to tighten them down, but it worked. All up, this thing weighs about 150 pounds, so it's not too bad to get down off of the bench. I did do that calculation before I welded it all together. Get this out of the way, move the welding table, and set it on its casters. Of course, my garage floor isn't even close to flat, but there it is. To mount the strut on the back, I'm using these 3/8 nuts. These just drop in and twist into position, and then they have these little plastic tabs that push down and keep the nut from rotating. I've always used the ones with springs on them, but they're really cumbersome and they're difficult to slide around, and these are much easier, and they actually ended up being cheaper. So with those nuts in there, we'll just run some bolts through the holes we drilled earlier, mount the struts in place. The last thing we need to do is put these rings on top. I think I know where they're going to go, but just to be sure, I'm going to tack them lightly. We're using the Matt Wetzel no-look tack technique. Just line the torch up, close your eyes, look away, and squeeze the trigger. Note that I am wearing a glove for safety. Get all 4 of these tacked on, and then we'll go around and put 2 more tacks on the sides just to make sure those are nice and secure. To load the cabinet into the frame, I will start by setting 2 of these feet down on the ground so that it won't move around on me. Now, I thought of some really clever ways to do this with the pallet jack and cribbing to avoid manual labor here, but I didn't think about those things until after I was done. So you're going to get to watch me do it the hard way. I'll just raise up the pallet on the jack here, get it to the right level, and slide this in. It's a little bit too high, so I'll adjust it. And then it's just a matter of forcing it in. It fits. There's about 1/4 of an inch of clearance on every side. It's just a matter of convincing it to go in. Like I said, I thought of some clever ways to do this after I did it the hard way. Lift those feet so we can roll it around. And this is where the electronics will mount, and the front is where all of the things go, in the drawers. It's actually a pretty good fit. I like this. I do want to actually anchor the cabinet into the frame just to keep it from moving around, so I'm going to put a couple of rivet nuts in the back here with some 1/4 inch fasteners. I'll just mark where those need to go, move the strut out of the way, and then drill some holes to put in the fasteners. Just mark the location and drill through. There's 2 or 3 layers of sheet metal here, and I'm just using the same step point drill bits for this. Of course, I'm doing it with my left hand and trying to work around the camera, so I got it in the wrong spot, and I'm trying to angle the drill to get it into the correct position, and this did not go well. Just assume I came back with a file and a punch and cleaned that up, and this is the hole on the other side. Behold, I'm using my right hand, and it went in sort of straight. So I'll just put in a rivet nut using the insertion tool here, squeeze to expand it, and then thread the tool out. Now with 2 rivet nuts in place, I can just put the strut back in, and I'm using 1/4 20 fasteners with a large fender washer. And I'll just tighten these down, and it should draw the cabinet back. It doesn't really have to hold any weight, it's just to keep it from moving around. And once this thing is loaded with tools, it's really not going to slide around anyway. And that's that. After a year of sitting on my floor, it is finally time for this router to go into its new home on top of this stand. Now there normally isn't a good way to lift this Avid router, so I had to make some tools to immobilize the gantry. These are just laser cut from 1/4-inch steel plate and bent, and then anchored with a couple of screws. You've seen these before because I 3D printed some of these and used them in my 3D printer test videos. But in this case, they're steel, and they're just anchored in here with a couple of channel nuts, and there's 4 of them to keep the gantry from moving. Then to actually do the lifting, I've got another 1/4-inch laser cut plate that just mounts with 8 more nuts and 8 more screws to the back of the gantry and gives me a good solid place to lift. You wouldn't want to do this without immobilizing the gantry first with the anchors, but I just moved the carriage around until I found the balance point, locked it in place, and that's how I lifted it off of the table where I built it and onto the stand. I don't have anybody here to help me, so I'm just going to move slowly and carefully 1 step at a time and stay out from under the load. I've been thinking about this for about a year, so I've thought through all of these steps, and I'm pretty sure this is going to work. You can see I have the stand up on blocks. That's to provide additional clearance for the extended legs of the engine hoist so they can slide underneath. And I should be able to get this in place and reach where it needs to go. Now I'm going to lower it just a little bit, just enough that I can get 1 foot into its ring. It'll stay. I can lower it a little bit more, and then work another foot into its ring. And then I'll lower it some more so most of the weight is on the stand, but not all of it. And then I can shift it into its final position, get the feet centered where they need to go. And then I can take the rest of the pressure off. And we're done. Of course, because my shop is small, I need to fold this up and get it out of the way so I have room to work. And then I can grab the pallet jack, lift this, and get it off of the blocks. As always, the 3D model and the drawings for this project will be posted on Patreon if you're interested in building one for yourself.
Fabrication is always a lot more work than I expect, and there's more to come, but I'm really happy to be making some progress on this project again. And my horrible welding was starting to look a lot less horrible by the end there. It's amazing what a little practice will do, and a good welder. If you enjoyed this video or found it useful, give it a thumbs up, subscribe, and maybe consider supporting the channel over on Patreon. If you're already a patron, thank you. You make it possible for me to do this. Thank you for watching.